Okay, this problem is rotate the list. Rotate the list means rotate the linked list. So head is given, head of the linked list is given. You have to rotate the linked list by key places to the right actually. Okay. So what are the constraints? Are the number of the nodes? Okay, fine. The value of the node, that is not, there's no use of this in our problem. The value of k, most important. So if you notice, the value of k is 2 into 10 to the power 9. So too much higher than the actual size of the linked list. So that means we have to rotate multiple times. Okay. So this can, if you do for big of n also, but it will take a lot of time. So you have to reduce. You have to reduce the value of the customer. Let's see what we could do. Let's first see the understand the problem. Okay. So assume this linked list is given. Okay. So in this case, what is the rotation one? Rotation one, that is k equals to one. That meaning k equals to one, so rotate by one places. So round one, so I can say it is a k equals to one. So what happens when k equals to one? So what happens, like zero? This zero rotates, shift to the right one just right side. One also goes to the right side, and two becomes the beginning, like it becomes the head. So that's why 201. Simply again one rotation if you do, so that time directly if you consider directly, it is still k equals to 2. So if you consider from the actual linked list, so it becomes like 0 goes to the second place, 1 goes to second place, means that means 1, and 2 go to the second place, that means in the middle. That's why, like, from k equals to 1 rotate again, so that's why 0 goes right, 1 goes come here, and 2 comes here. So that is as simple as that. Similarly, k equals to 3 is k. There is a nice thing, like when a k equals to the third rotation, it becomes the original linked list. Like again, it is rotated one time, so like it becomes here, it comes here, it comes here. So again, it becomes this thing, it becomes the original thing. Okay. So k equals to 4. So let's say it's k equals to 3. This is k equals to 4, and let's draw something round 5 or rotate 5, whatever you can say. It will become 1, then 2, then 0, then round 6, that is 0, 1, 2. So can we see the any pattern? Just notice once. So the pattern is, see this thing. So at the third, whenever the k equals to 3, that means third rotation, it becomes the original. At the sixth rotation, it is also the original. So why C6? So length of the linked list is 3. So at every multiple of the length of the linked list, I get the original linked list. Okay. So if I know 6 is equivalent to 3, 3 is equivalent to what? It is actually K0. There is no movement. So if 6 is equivalent to 3, 3 is equivalent to 0. Why should I work? Okay. Again, if k equals to 5 is equivalent to k equals to 1, why should we think of it? Assume like k equals to 26. 26, should I move for 26? No. I can find out the modulo of it. Like we can find, like it is a modulo, like k equals to modulo n equals to the actual value. So modulo means it is finding the remainder. So here if we do like k equals to 4, so 4 modulo 3, because n equals to 3, it becomes 1. So if you notice, this is exactly same as the modulo rotate one. Similarly, if my k equals to 26 is given, so should I rotate for 26 times? No, I can directly do 26 modulo 3, that is 2, I guess. So that is exactly like I can directly do it from here. Rotation is 2. So I can reduce the value of k. So what right now then what I need, what I am getting is k. I have to do k modulo n and reassign this value to k. So right now what we need, k is given, and what is given, n is not given. Head is given. Head of the linked list is given, but this n is not given. So we have to find out the head of the linked list. Right? So that case. let's see like how to calculate that. Fine. So this comes to the bigger problem. Here assume that my k equals to 3. K equals to 3. That means if k equals to 3, so every element of the limit is rotated 3 times. What will be the final outcome? Final outcome will be that 1 comes 3 times, like that means here, then 2, then 3, then 4, then 5. So this is the final outcome, final linked list. Okay. So if you notice right now, right at this moment, 5 is pointing to the null value. That is end of the link list. Right after my rotation, 5 will come to the point to this 1. Like right now, 1 is the head. So after my rotation, 5 will point to the head, actual value. Whatever the thing is right now, see here, whatever the tail node or end node it is, it will, after the rotation, it will obviously always point to the head. Always. Doesn't matter. Like it is a k equals to 3. If I make k equals to 4, what will be the case? So let's do k equals to 4. K equals to 4. So in that case, my linked list should looks like this, right? So like here, 1 comes here, then 2, 3, 4, and 5. So again, see, 5 is pointing to the head. It doesn't matter if you shift this side or this side, doesn't matter. Like at the end, like until k equals to 0, that is the original link is everything, every time this my tail node will point to the head node. Okay, fine, good thing. So I'm denoting the yellow color. What will be my next process? So 5 is pointing to the now see which element is currently my head. If you notice, then 3 is currently pointing to the head. That means the node before the 3, it should become tail node, right? So tail node becomes it should point to the like none, nothing. It should point nothing. So this 2 becomes nothing. Okay. So this is the case. Okay. Now understand like how could we get the tail node? How could we get the number? So what do we need? I need earlier I need what? Earlier I need my value of it. Second what I need? I need always need my tail node. I need always my tail node so that I can point to this to the head value. Correct. So I can do that. I sorry first make a list what I need. Tail node is needed. Fine. After that what do we need? We need the value like finding the current head or before the head. I need this thing. What is the current head position or this position? Now, if you notice carefully, what is the position of the two? What is the position of the two? Position of the two. So I am considering the first one position, two position, 2 position, 3 position, 4 position, 5 position. If my value is equals to my x3, k equals to 3, then what is the position of my next head node? It is the 3 position, right? And what is the position of the previous or this should be my position of the node, right? The tail node. This would be my new tail node. What is the position of the new tail node? It is n minus k, that is 3. Sorry, 2. N minus k, that is 2 here. 2 here. Similarly, if you consider that k equals to 4, k equals to 4 means what is my tail node? Tail node will become my 1. See this one is the tail node. So what I need actually, and if I get the tail node, and now see if I get the tail node, and what is my head? This will be my head. If k equals to 3, this will be my head, and this will be my tail node, right? New tail node. So should I go to the head node or should I go to the tail node? Find the tail node. That's a good question. So if you like, what I have to do at the end, I have to make the tail node at a null, right? I have to next node of the tail node will be none. So I have to make this thing as none. Currently it is pointing to the 3, right? So if I find the head node, can I get traverse back to my previous node of the head? No, right? It's not a double list, it's a single list. So if I get my this node, I can easily traverse to this one, and after that I can store the value and I can make it as null. As simple as that, right? So I don't need my current head node. I need what will be my new tail node, right? You understand? So I need the third thing, like new tail node. After I am getting a new tail node, I can backtrack. Okay. So let's start about the pseudocode. As well as I will not give you the any specific coding, I show you on Python code, but I will give you the pseudocode which will you use in any language. So let me copy this and paste this here. I don't need that much. This is fine. Okay. So let's my first target is what? My first target is finding the tail node, right? So and also the current number of the linked list. Okay, number of the linked list. So what I can do, I can head is given, and that but I cannot directly traverse from the head. So what I can do, my current let me my I need a tail node, right? So I am writing the tail variable. Okay. So I'm pointing the tail. I'm assuming my tail node is right now here. Right now my tail node is here. This is my tail node at the end. At the end. And what is the current number of the linked list? That n is my currently n one, right? N is my one at the present. Now I have to go to the traverse till the end. Traverse till this node, right? So what I have to do? I have to check when what is the, let's say, when how can I understand like this is my tail node. See, before this node, every node has any value. Like all you know, a linked list has two things. One is data and one other is next. Okay. So in that case, you see the next value here is something. The next value of this node is something. 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 But see, next value of this node is nothing but none or null. Anything you can say. So in that case, like whenever I got my next value is null, that means I already reached my tail node, right? So I will simply put a while loop. While tail node next value of tail node tail dot next is equals to not equals to sorry, not equals to null, while the tail of next is not equals to null, or we can say not equals to null, we will traverse, right? We can traverse whenever it will null, it will become it will stop. So we can traverse. Let's traverse. Traverse what? And what I have to do in traversing? I'll simply have to just increment. Like what are the things I have to increment? I have to increment my number, and also I have to change the tail. So tail will become this. Tail will become next tail. Tail dot next. Tail dot next, and n will be n plus plus. It will be increased and tail will be 10 on next, right? So my tail, this tail will come here, and n is what? Right now my uh, n equals to 1, n was 1, so it becomes 2. So is it my next position? Like it is my, if the tail dot next not equals to null? Yes, tail dot next is not equals to null. So that means I have to traverse again. So that time tail will comes here, and n become 3. Again, let's see, like tail is null, tail dot next is null, no, right? So I have to again traverse. Tail will become tail equals to tail dot next, and n will become 4. N will become 4. After that again tail dot, is it null? No. So it will become here. So it becomes 5. Okay. So 4 equals to 5 here, see here, right now see tail dot next equals not equals to null. No, this is the case. Like this is here in this point, tail equals to null. So I can't traverse. And we also get what I get what my n becomes 5, and I got my new tail node. So in my checklist, I got my n and got my new tail node, right? Now what I need simply I need new like new tail node. New tail node means like what would which node will become the becomes the tail node of the after the safety. Okay, I need that. Okay, let's find it out. How can I do that? Okay, so this here. Okay, now let's do what? Let's do like now my see like what on which position I need to go. And I have to go. I told you earlier. I need to go k minus n node. So new till node, find a new till node. So that checklist I can rewrite this thing like this way. Like find new till node or k sorry n minus kth node or n minus kth node, right? This is my at the end. This is I want an it. Like see, I told you like if k equals to 3, my new tail node like new tail node of that shifted linking list, it looks like equation that n minus k is position. If my k equals to 4, one becomes the list. Then again n minus k, that means one position. So I, I need to go to n minus k position. Okay. So I have to starting from here, and I have to traverse till n minus k. Okay, so this is how I have to traverse. Yeah, but before that, what I have to do, I told you, I did this. I got in until on one step. Forgot to mention here. I also have to do what? I also have to find k equals to k modulo k minus 10. Right? That also I have to do, isn't it? Like k equals to k modulo n. That step also I have to do. Like reduce the value of the k. That is the we have did at the beginning. So that step is also needed. Like I have to do k equals to k modulo n. Okay. Now we have to traverse to the new real node, right? So I know like I have to traverse to n minus k node, right? So again I can initialize like this way. Like my current value will be 1 and current position is 1, and this is my current node. This is how I can traverse. Okay. So if I do this thing, let's see, let's do a mistake. Then I'll explain why I'm doing that mistake. So let's traverse. So let's traverse like if I do like my current is current position. I am need my current goes to head. Current will be head, and my new position like current position is first node, right? Position is 1. If my position is 1 and current is head, if I now what I can do, I can do like if I do like if you want to go to the second node or k in minus k node, like what you will write simply, you will write simply like while my position my position is less than or equals to my n minus k. So that whenever it will be greater than n minus k, it will stop. So simply we do write this like whenever I have to reach that specific position, I do n minus k, or that specific less equals to that x. Okay. So if I do that, let's see what will be the problem. So here my k value is here my k value is 3. So n minus k is 2. Remind this. Okay. So let's if I do that. So whatever I have to do, simple previous like previously what I did. So this will be my current will be increased. I have to uh, iterate the current. So current will be current dot next, and my position plus plus, right. So if I go walk through this pseudocode, let's see what will be a case. See here, my current is initially here. This is my current. Position is 1. So in that case, like whether current one position is 1. Okay. Okay. So see, if my current position is less than n minus k is 2. Yes, it is less than n minus k. Okay. So I have to move to the current. Current becomes here and position becomes 2. Again, I have to see, I'm already in current position. Now, if I iterate once again, then I will become to the next place. Okay. So, but the things what I written the condition I have written like n less equals to n minus k. So right now also like n minus k is what 2. So what I am saying like if I am doing that thing like now it is n minus k. So if I write that thing like it becomes position will be 3. Position will be 3. Now my current will be what? Current will be current dot next. It becomes here. So right now my it is not less equals to 3 because position becomes 3. It is greater than n minus k. So now loop will break. But the thing you notice like what I got my new head instead of my current like a new tail node, right? So I cannot write n minus k direct. I have to write in less position less than n minus k. That is the condition I should write. So if I write the condition, let's iterate again. Initially, my position is 1, and this is my current, and it is head. Now, if I write n minus k, so first n minus k position is 1, current is n minus k is 2. It is less, yes, it is less. So increase the current, shift the current, and increase the position. So it is 2. Is it less than 2? No, it is not less than n minus k. So I have already reached my position. So here I can right now I can do the step. I guess you got it why I am doing n minus k. Okay. Now let minimize this thing so that everything comes in the same picture. Okay. So now what are the things I have to do? I got n minus. So right now what I need to do? So I need to this thing becomes my new head, right? And this I have to make it null. So simple I have to if you say it is a make it null, one mistake we usually do is simple right like what? Simply right is let's say this one is simply right like current I got the current is my position neutral so current dot next I'm making it as null and I will do my new head equals to new head. I make it that current dot next. Okay, current dot next. So is it a case? See this. If I do that this step early, like current dot next equals to null. If I do this step at the beginning, so what will happen? This will remove this link, and this becomes null, and this list becomes discontinuous, right? Okay. So what I have to do, I have to first assign the new head first that current in a new head equals to current dot next. Then I can write this thing current dot next equals to null. So I have to write this thing to this thing, right? This is the thing and null, right? And another thing, this is now what? Now one thing we missed. Like this is the still now I didn't assign my still now I didn't assign my tail node to the head, right? I told you whatever the condition is, tail node will point my head node, right? I also write that condition also like my I'll just tell the tail dot next. It will point to the head node right now. So at the end it is done, and at the end what I have to return? I have to return now. Let's return my new head. Return my new head. So this is the condition. Now this is the case for every like what should I say? This is the case for like normal cases. Now let's think about the edge cases. There is edge cases as well. So what are the edge cases? First of all, like if my k equals to 0, if my k equals to 0, should I do I need to rotate? No, right? K equals to 0. Why should I rotate, right? So when I got the kth value, reduce the kth value here, I have to check if it is 0. If it is 0 means then I don't need to do any stuff, right? I can simply say return. Right? So I will simply say return. So let me write that as well. So let me write if my k equals to 0, then simply what? Return the current head. It will be in the head. No rotation. Return the head. Okay. This is one edge case. Another edge case we all miss, like this is my head. This is no problem. This is my head. Okay. And this was the new head actually. New head. This is my head. What if the linked list doesn't exist? Like if you notice carefully, if you noticed carefully here at the constant, what it is showing, linked list code, length of the linked list means 0. That means nothing is present. Head is pointing to null. Okay, head is pointing to the null. So in that case, I have to check that also. Like if linked list already exists or not. If it is not exist, no need to return anything. Like return none or return the head only. Oh, we can do that. So if the English list, that is the after that we can rotate, right? If it doesn't exist, what should we rotate? So that thing is also you have to add this thing like at the beginning, at the very beginning. If head is equals to null, then also return head. Then also return head. Okay. So these are the causes. So it is a very simple thing. Simple algorithm, everything is simple. But the thing is, it looks like a lengthy one, but it's a very simple. English is very, very simple, but it sometimes becomes lengthy actually. Okay, this is the case. I will show you the Python code. Let me add the Python code, and I guess you from this pseudocode you can obviously find out what the code will be code in C++ or Java. All right, please write your code in Java or C++. Okay, and let me give you the Python. So this is the Python code, and here what could we see? Like as I told you earlier, I have to check head equals to null or not. If it is null, I return the head. Then again the same thing. So TL equals to here, and it's as pointing to here. Then while till dot next not equals to null. So this is the Python. You can write that while till dot next. You can write till dot not equals to null. And so again in plus one or TL equals to L dot next. Now again I have reduced the value of k. If k equals to 0, then also return the head. Then I'm routing the position and current is here, position and current. And after then again position is n minus k less than n minus k. I'm changing the value like current equal to current dot next and post position plus equals to 1. Then assigning the new head equals to current dot next. Then making this next equals to null until dot next equals to head. Return the head. Okay, let's see what is the time complexity. Here we are returning like iterating to entire lineage. So obviously this part is big O of n. Correct. Again here I am iterating to n minus k. See here, if n equals to 1, if I assume n equals to 6, and or you can go to 116 and k equals to 1. So n minus k will be what? N minus k will be 115, right? So it is also in the worst case, it is also big O of n. is also big O of n. So, and this is the normal assignment, so it will not take any big O of font time complexity. So it is big O of overall time complexity is big O of n. So time complexity will be big O of n of this problem. And what will be the space complexity? Do we use any extra space? No, right? So space complexity will be big O of 1. No extra space is being used. So this is the thing we did. Yeah. Thank you. As always, if you find any mistake, please comment it down. And if you find any good video, and on this also refer me, then I will also run. Okay then. Bye bye.